that my mind is breathing in. Break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless. Burning the bridge that keeps us.
Can you guys hear me? Can you guys hear me? All right. Actually, the countdown music was dominating.
I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear I weighed the person you are. Oh, break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless. Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless. Burning the bridge that keeps us. I'm here and I'm feeling fearless. Exaggerated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear I weighed the person you are. Oh, break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent.
Hey there. I'm back. So happy to see you all again. Welcome to my stream. Okay. I guess I'm all set to begin this. Let's see. Okay, fine. So what were we doing? In our previous stream, if you have watched, we were trying to analyze a malware from Hack the Box. So we've been solving Hack the Box Sherlock, and I'm just going to continue what I was doing yesterday. So that's what I'm going to do right now. I have my malware lab ready. So all I need to do is to spin this up. I'm doing it right now. Before I start sharing my screen and I'm enabling the recording, I just wanted to give you an insight and also a self-introduction, a bit of self-introduction. My name is Perumal Jagan, and I'm working as a security researcher at an MNC. I do love making contents on cybersecurity. In fact, I love cybersecurity. I really admire it. One of such a fascinating field cybersecurity is. There are plenty of things to learn. Always you will have a lot of things to learn. Not something, lot of things to learn. So it's gonna be the case every time, even if you do the 24/7 learning, which is literally not possible. And actually there are a lot of divisions. There are a lot of specializations in cybersecurity, if we can say. I mean, application security, forensics, offensive security engineer, penetration tester. Offensive security, penetration tester, red teamer. There are various designations. There are plenty of designation inside cybersecurity. It's kind of a superset of a lot of security oriented specializations. That's what I would say. And I really do love exploring all these things as much as possible. That's my wish. I don't want to keep myself within a boundary, within a specific specialization. So that's why I used to do malware analysis, forensics, penetration testing, sometimes red teaming. I haven't done this on stream, but I also have. I have an interest to learn all those things. So today, as I said, we are going to continue the malware analysis that we were doing yesterday. Okay, that's the aim. And we've been analyzing a Golang malware. So the challenge called Malevolent Mod Maker. So before I do, I just get into the. Give me a second. Before I get into the analysis, so let me give you an insight like what we did yesterday and what we are about to do today. Okay, hold on a sec. I have VM ready. All I need to do is to log in the Hack the Box platform. So that's what I'm planning to do right now. I did logged in. Give me a second. Yes. So let me start sharing my screen. I hope you guys can see my screen. And here is the challenge, Malevolent Mod Maker. Bob, a senior software engineer at Acme, was taking a break from correcting AI code to check in his favorite gaming community. One of the newer members had a new program that can make mods for popular game. Eager to try new things when he ran as an administrator as instructed, all of his files are deleted and replaced. He immediately called the help desk, so they locked his machine and incident response was called. And that's the scenario we were up against, and we are given a zip file with 4 megabytes of size. And I have already did the analysis. We did some basic analysis, so here is the sample. I brought this sample to my analysis VM, and just here is a brief intro to my analysis VM. It's a Windows VM with the Defender disabled and with some basic tools installed. So that's the setup. And also I haven't configured the network interface for this very VM, but so it'll be like an isolated setup, okay, isolated machine. So that's the part. And now if you see, there is the folder, and within this folder there are 2 files. In fact, within this folder there are various files. So these are the malware files actually. The MC ModMaker version 1.4.exe is the first that ModMaker executable. It appears to be executable, but also stealthily it has been installing malware. The malware called the executable called goteam.exe. So this file was actually downloaded by this ModMaker executable, and this is actually a ransomware. We were able to confirm this via a virus total yesterday. So we've been analyzing this MC ModMaker version 1.4.exe. In my previous stream, I used tools like Floss and Kappa to test or to deduce the behaviors of these binaries, and it clearly mentioned that it is doing some encryption task and using HTTP protocol as a C2 channel. So that was our observation. And here is the d.text file, which is literally a ransom note, and you could see this here. Here is an extortion message, some BTC address, some address, and here is the decryptor. They also gave the decryptor binary bruh.exe and also the usage. The only thing the victim need is the decryption key. If they have the decryption key, it is possible to unravel the encrypted data. And the encrypted data you can see here. Probably important .text.goteam. So goteam is actually an extension that doesn't make sense. It's a custom, a weird extension, which is a typical ransomware behavior. Ransomwares usually do apply the extensions like this, so that it cannot be accessible by, it's a corrupted format, not a corrupted, I would say an encrypted format. A kind of they did the encryption and they applied some custom extension, so that the intention is to cripple all the files on the file system. So that's the intention of ransomware. And to reveal or to release all those files, they try to extort the victim. So that's the plan. That's been the plan always by the ransomware actors. All right, I think we gave some insights. Now today what we are going to do, yesterday actually I was trying to use Ghidra to do some static analysis, advanced static analysis through Ghidra disassembler, but I couldn't do it. In fact, I was struggling a lot, but I actually took some notes. I actually read some blogs today, so hopefully I'll be able to pull this off. Okay, so that's the plan. Let me go and start the recording. Okay, I'm gonna start the recording now. So you guys might know, like, I used to record while I'm streaming, so that's what I've been doing. So that's what I'm planning to do now as well. Let's see. Okay, so I'm starting the recording. Hello everyone, my name is Permal Jagan and I'm so happy to be back. And today we are going to continue what we were doing. Okay, we are going to do the malware analysis, the Golang malware analysis that we are up against, and we already did few things. We used tools like Floss, Kappa, and PE Studio to analyze its portable executable headers and its imports, the syscalls that the Windows API calls that it has been importing, and also we used FOSS and kappa to reduce the behavior of the binary. Okay, now what we are going to do, we are going to do some disassembly. We are going to use Ghidra, tools like Ghidra, to disassemble both the binaries. So you know very well we are actually up against two binaries, and you can see here this particular binary is the main one, MC ModMaker version 1.4.exe and GoTeam.txt. So this is appears to be the ransomware binary, and here is the ransomware node. We have already seen this. Fine. Now it looks like the decryptor bruh.exe. It's the decryptor. It is given. So all we need to do is to disassemble this binary and find the key of decryption. So that's the aim. In my previous parts, I've struggled a lot to disassemble or reverse this Golang binary, but hopefully I actually did some work, and I'll be able to come over that. Let's see. Okay, I hope you guys can see the screen. Fine. Now I have installed few tools actually. I reverted the VM state to the fresh one, and I installed tools like Commander. So hopefully it's gonna help me to use some Linux oriented commands over Windows to list the directories and all. All right, now what I can do, I actually need to do some reversing disassembly, right? Okay, first of all, let's see what are the questions we've already answered. Right from the start, based on incident history, the text file contains the extension append. Okay, actually we read the file d.txt, and it revealed it was actually a ransomware. So that's what we've answered. And what mechanism does MC ModMaker version 1.4.exe use to send information back to C2 server? And it was webhook. Let me prove that. Previously I was not handling the Ghidra properly. I was quite struggling because it's been a long time since I've used it, so I struggled a lot. But now I guess I got a clarity. Let's see. I need to go to desktop. Inside the desktop, advanced static analysis, Ghidra, and I'm starting the Ghidra utility. Inside Ghidra, I have already loaded the binary that I need. So I'm simply going to open that and analyze. When I was doing the work, I did load the second binary as well, but now I guess it is time to assess the first binary. Okay, let's see. Open. Yes, so I actually opened this ModMaker version 1.4.exe. So here is the program tree and symbol tree that loads the import, export, some namespaces symbol. Usually what we do, we go to functions if it is a C or C++ binary and check for the main function. But in Golang binary, fine, analysis found in the symbol entry. Would you like to go to that symbol? No. Okay. Now actually, as I said, in C and C++, we check for the functions, the main functions inside the functions directory. But here in Golang, we should go to namespaces. If you go to namespaces, when you scroll down, you would find a place called main. So this is what holding the main function. If you see, here is the main function. So I'm clicking this main function, and you can see the main function is opened in the decompiled view and also the disassembled view. This is the disassembly view. This is the decompiled view. Now I'm simply scrolling down. I hope my picture is not hiding. I'll try to keep important things in this place. Okay, now I'm scrolling down. If I scroll down further, I could see a function called run command. Then if I scroll down further, I could see a function called main.send to discord. So looks like this is the function that actually trying to reach a Discord server. Maybe it would be trying to use Discord as C2, but I don't know. Looks like here you can see Discord API it's been trying to reach, and I could see the webhooks. So let's see what is webhook. So just a learning here. What is Discord webhook in malware analysis? A Discord webhook is a unique URL that allows automated messages and data to be sent to a specific channel via in a Discord server. In malware analysis, attackers often exploit Discord webhook to communicate with a compromised system, sending stolen data and receiving from commands. Okay, looks like it's a unique URL that allows kind of opening a unique channel for C2 communication. I think that's what the Discord or the concept of webhook is all about. Fine. Let me go to the malware VM, and here is the answer. So in this particular URL, it clearly says it is webhook. So that was the answer. We already did answer to the question. It was the second question. Now let's see the next one. What command does modmaker version 1.4.exe run suggesting? It means to execute other binaries or scripts. So they say the MC modmaker is also suggesting to execute, suggesting that it means to execute other binaries. Okay. So they are actually asking us to find the command that is actually executed by this executable. That command actually has the capability to run the other scripts and binaries. Now I go here, we have seen the run command function call, right? So let me take that. Here is the run command. So I'm just clicking the run command, getting into that subroutine, getting into that function definition. And here, if I see with my bare eyes, I do not see any interesting comments, because we usually see these things in comments, like here, the commands that you use to execute, but if it is added. But here, I don't see any command that has the capability to run binaries or scripts. But how I can find this? Maybe I can use a dynamic analysis. I can use some debugging tools to analyze it. So this is where actually when I was struggled, I did refer some write-ups, and let me open that write-ups. I'm not shy to open and show these write-ups to you. So let's learn together. That's the important at the end. Malware mod maker write-up. The official write-up was actually not giving me the information that I want. Let me tell you this, how I'm actually telling this. Malware analysis, malware mod maker. Come on. Yeah. Malware mod maker. And here, if I open document.pdf, here if I scroll down further to answer the third question, you can see they are also referring the same run command, which is part of the main function, and also the malware uses curl command to retrieve the ransomware binary, presumably send the data back to API. Actually, we have seen that in our previous parts when we were analyzing the strings. There were some couple of curl command usage, but now here you can see some comments. I don't know which window it is, but hopefully from another write-up I got to know this is actually came from debugger, x64 debugger. And you can see the list of comments here, and this is the answer. This is going to be the answer, but the point here is how we are going to find this ourselves. So that's what I'm just trying to do right now. Let's see how I can achieve this. I was actually about to open a write-up, right? So let me go to my browser. Yes, I think this one. So here are some write-ups. Malware mod maker, Golang based ransomware, dynamic binary analysis using x64 dbg. This is what we are about to do right now. And static binary analysis using Ghidra and detect it easy. we have used detected TC already. Now go to this write-up, and here is the MD5 file. So let's go here. So we already did all these parts. So we found its Golang binary and we opened this file. The second question is webhook. Actually, we have spotted that this webhook part as well by using our Ghidra disassembler. Now the third question is this one, and the answer is this one. But how to find that? To identify which commands were used to execute the binaries, I manually debug the sample using x64, passing the execution just before the webhook was called. The simplest approach is to search for error strings and any other strings of interest. Okay, I haven't used x64 dbg on the stream. Maybe this is gonna be an interesting stuff. Now if you see, inspect the offset from, we identify this particular command. So when they were investigating on x64 dbg, they found this part. All right, without further ado, let's go. I go to this lab. I'm launching x64 dbg, which is already installed here, and I'm opening the file. Let's go to modmaker, malevolent modmaker, danger, modmaker version 1.4.exe. Opening it. System breakpoint reached. So whenever you load an executable file, it hits the system breakpoint, stops at the beginning. Now it is our role to put a breakpoint in a specific spot. Okay, so that's what we need to do. Maybe I'm just I've never used, it's been a while since I used this, so I might be struggling, so bear with this. Let's see. So it's an incredible tool actually to use. I go to options, first of all, to just maximize the appearance. Font, maybe how about using 12? 12 looks okay. Yeah, 12 looks okay, right? I think it is clear enough now. Or maybe 14. 14 is little more better. All right, so I'm just making it 14. 14, 14, 14. This font is fine. Okay, now I tried maximizing it. Now I can see this even clearly. Comments are comma separated, move AAC EBA. So let's learn this x64 reversing, debugging, to be frank. So let's see what are all the steps to follow before we how to apply the breakpoint and execute, and how to do the step-by-step execution. Or let's see all these things. x64 dbg cheat sheet, maybe. Can I get the resource? Yeah, shortcut or cheat sheets. So here is the command page. Command argument, argument 2, argument n. Okay. General purpose command. Yes, so here it is. File, open, attach, detach, exit. So now this is fine. Actions, find command, find in current mode, find strings in current module, go to previous reference, next reference. This is fine. Breakpoint. So here is the stuff. Toggle breakpoint, conditional breakpoint, toggle bookmark, delete breakpoint. So F2 is to apply breakpoint. But before that, I should stop at main function. How I can stop at the main function? Let's see. So this one is actually run, this one is actually pause, this one is actually close, step into, step over, trace into trace over, execute till return, run to user code, Scylla, patches, comments. It's a powerful utility. If you learn this, then you'll be able to uncover plenty of things. But settings saved is okay. I'm getting a message. But how I can get into the main function? How to search them? Let's see. Control F if I press main. Can I go to main? No. I don't want to execute this fully. So when the program opens, it actually stops at the entry point, I guess. Let's go and read this. Running F9, run until selection, pause, restart, step into. Restart is actually Control F2. Control F2 or like this. Yes, now I have restarted this. Now you can see I'm actually at some point. I'm at this particular address. Let's see. This cheat sheet would be very helpful, but let's start from scratch. After loading exe file, how to jump to specific function, or how to apply breakpoint in main function. Using the symbols pane recommended. Load exe, okay. Wait for the analysis, execute will be pause the system entry point, okay. Wait for the initial analysis, complete. Navigate to symbols tab in the lower left pane. Left lower. View symbol info. Yeah, there it is. So this is the CPU view, and symbol view is actually not here, but when I click symbol view, you could see them clearly. Symbol info is not yet loaded. RT is user, so it is relying on these DLLs. Okay, now let me take a screenshot of it. Copy this to clipboard. I go to this. I go to AI. How to run this? Maybe if I run, what happens? Let's see. if I run, debugging stopped or terminated. Did I infected the machine? I guess I did infected the machine. I just messed with the machine. But not a problem. I guess this one is still sandbox, right? Isolated one, not connected to internet, so no problem. Maybe what I can do is to reopen the file modmaker.exe. Okay, I have loaded them. Command bp. I should put the breakpoint in a main function, but how I can find them? Typical pause at the system entry point, waiting for the initialize to complete, indicated by the status bar at the bottom. Navigate to the symbol, look for the name of the executable file in the list, expand it, search the symbol main or winmain. Okay, I think I should click this from symbols entry. I should go and click them. Symbol info. Come on. Gosh. I go to symbol info again, and if I just click this symbol, this particular binary, when I scroll down, I could see bunch of imports and exports, but where is the main function? So let me check this out. Tracing plugins. Symbol info. Modmaker.exe. Address of the entry point 840 C0. So this is where it is. Yes, and you see plenty of things here. A lot of functions getting imported from kernel 32, but how to find, like, where to stop, like where is the main function, how I can find them. Let me go and search here. So this is the symbols pane, right? Can I go and take a screenshot of it? I go and get the help from ChatGPT now. Not gonna hesitate because I'm learning now. ChatGPT. Yes, I know. I am learning. Malware debugging with x64 dbg. How to I open the binary. Now how to do I have any text file here? No, not here. Inside the infected VM. Do I have any text file in this directory? Come on, sample mod maker. Mod maker danger.txt. Since I have executed the binary, I wanted to check whether any files got encrypted now. Okay, now I go and do this ChatGPT query. I'm learning. I opened binary. Then how to get to main Golang binary to main function or apply main apply breakpoint in main function. Go binaries are very different from C or C++. So usual main breakpoint workflow doesn't work out of the box. I walk through how reliably reach go main.main next TBD. Okay, I think let's see. In PE entry point is not main.main. Executable flow is roughly entry point runtime. So runtime.main then main.main. This is what you want. So if breakpoint at the entry point, you are far away from go main. So that's what. And let's let the program run until go runtime is mapped. You pass the system breakpoint, good. Press F9 once or twice until the program actually starts running go code. Then pause again. What? Control F2 or pause button. Okay. F12 or pause button. Find Go runtime symbols even without PDB. Go windows usually contain their own symbol names. Go symbols tab. Alt tab. Search for runtime main and main.main. Okay, if you see runtime.main, right click breakpoint toggle. Manually locate main.main via strings. Very reliable. So let's see this one. Search current module string. Okay, let's see. Search current module string. Can I see them? Modules. Can I see anything? No. How about strings? We already reached the 28-minute mark, but I'll try to just fix this. How to go to strings here? I think first we need to run the binary. Still it is in the system breakpoint. First we need to run. For that, F9 one or twice the program actually starts running go code. Then pause. Okay. F9 to run the program. Then pause. I should press this one. Okay. F9. Come on. F9. No, it's not working. F9 if I press. Okay. Now what happens? Look at this. Here it got changed. So the F9 is the path. I did press F9. What happened? Actually it ran. Like pressing this one. Now you can see the breakpoint entry point at address of entry point. Okay. Now it is actually at this particular spot. Now if I go to the CPU view, I do not see. Okay, let's see now. Again, I'm going to symbols table. I'm still seeing the same. Okay, let's see. I'll just paste this screenshot as well to ask a question to ChatGPT. Let's see what happens. Yeah. Copy clipboard. alphabet clipboard. Now let me go and paste this one. Gear traffic co plugin, IDAF Golang loader, before mainly runtime behavior and API tracing. You are currently paused at the PE entry point of Go binary. So that's what it means. So earlier it was actually at the system breakpoint. Now it paused at the PE entry point of Go binary, which is expected. Now we walk from here from Go. Now we walk from here to Go. Go's main.main. I'll give you exact the concept that you are okay. Let's see. You are passed at optional header address of entry point. This is not main.main. Okay. Now we are at the binaries entry point. This is Go's low-level startup stub and eventually calls. So it's gonna call this one and this one and this one eventually. So get to main.main step by step. How to do that? Double click. You should already be there. Just be in the case. Double click. Optional header. You will see disassembly instruction now. Really. If I click this, yeah. Now, yes, 840C0. So this is the entry point, and here is the disassembly of it. And now, I guess I am in that entry point. Then, from this exact paused state, press F9 to run once. Let it run. If it pauses again, quickly TLS loader breakpoint, press F9 again. Don't single step yet. Go to startup code. This is huge and slow step. Okay, I think I need to run it again. So let me do this. I run once again. It says debugging stopped. So I reached the entry point, but when I ran again, I completely did the execution. So the debugging is right now it's stopped. So how I can restart it? Maybe I can go and open this recent file once again. System breakpoint is reached. Run this once. Now the breakpoint is reached. So here's the the entry point. So it stopped at the entry point right now. If I go to symbols table, do I see anything, any interesting info? Let me go to symbols table. Can I see any stuff? I'm still seeing this binary and its imports, but handles, threads, CPU, address of entry point is totally fine. Can I search for the strings now? Since the binary is loaded now. How to view the strings? I need to know the address of the particular main function. If I know that, then it's going to be a piece of cake to apply the breakpoint there. Then resume execution. Come on. Okay. Now let's go. Search strings. Search current module string. So this is the label stuff. Let's see. Search current module string. Where is the search table? Current module string. to do string search here. We already crossed the timeline, the time mark, but anyway, let's see. You are on the CPU view exactly how to string search in X3 but you are okay. Right click anywhere, the CPU disassembly view, search for current module and the string. Okay. Search for current module. Yes, search for current module, string references. String references. Yeah, here it is. So this is what I was looking for. And here I should search main.main. Come on. But I'm not seeing this one. But this is the string, right? Now what I can do, maybe, how about searching Discord? Discord, can I see them? Go to not search for all modules, string references. Okay, sorry, main.main. Can I see them? No. Or simply main? No. Okay, how about running the step one by one? Step over. So it is running one by one, the instruction one by one. It's quite hard to adapt to this DBG. I have used GDB, but not x64 often. Current region command, constant string references, pattern, GUID. String references. Here are the strings, but what if I search curl? Can see curl, and if I check for curl, you can see there are two instances. So it literally says there. So here are the addresses. So it is actually trying to access one URL with https tunid.htv API v2 country city VPN. So looks like it is using this particular API. I think we are answering one question here. So let's answer this question and move on. I'm go and scroll down here. There is a question. Come on. Yes. What is the value of the API key contained within the URL, which suggests it to enumerate the geolocation data? And here is the, come on. Yeah. Here is the URL, hunid .htb API v2 country city API key, and here is the URL and this is the API key. So I guess I clicked it. Now I'm in that instruction. If I just scroll this side, yes, I think I got it. I think based on the string search, if you go, I think it works in x64 EBG. Now you can see we have reached the place that we want. I did not go via main function, but here is the thing. And here the command, here this is the URL and the API key is given here. Copy selection. Yeah. Now if I try to paste them somewhere, what I get? It actually copied the whole string, but this is the API key that I need. So I go and answer this, and that's the TLS. I think I should ignore this TLS at the end. This is the right answer. And what command does MC Bondmaker run, suggesting that it need to execute other binaries or scripts? And it's actually here. Save. Okay, and you can see this one. PowerShell execute. PowerShell EP bypass. So this is the command that is used to run the other scripts. And also you can see followed by this command, it tried to execute this goteam.txt as well. Yeah. So I copy this value as well. Copy selection. Come on. In this, I need this part only. PowerShell-EP execution policy bypass. I go here and put this. That's gonna be the answer. And now, what domain the C2 server serves the ransomware? What domain is the C2 server that serves the ransomware payload? Let's see. It's gonna be here. Here it is, and you can see this. So followed by this particular curl command, curl http :/goteam.stb :8080 goteam.exe. Seems this is what's serving the goteam.exe binary. We've already checked in VirusTotal. This is the ransomware binary, so it's obvious. So this is the domain name, goteam.stb. How about that? goteam.stb. So they asked the domain of the C2 server, and this is the answer, goteam.exe. So okay, now so far we have answered 5 questions. We yet to answer 6 more questions. I think we are already over the mark. We are at the 45-minute mark. So I'm stopping here. I'm going to continue this analysis in the next part. Okay, I think I did some debugging. I was trying to find the main function, how to find the main function. Eventually, I got the string and just moved it with the string by using the string. So it helped me a lot. Now it is okay, it is fine. I think I should be starting the next recording, the next part recording now. Maybe I think this time I'll be able to answer some other questions. Let's see how it goes. Let's see. Hmm. So before I start all these things, can I do some simple exploration maybe on a platform like try hack me? So here we are struggling a lot, right, to use x64 DBG and all, but I guess there are some exclusive rooms in uh, try hack me. So if you see x64, or I think there is a room called debugging. So it completely talks about this one. I finished this room, but it's been a while, so I really lost the rhythm. And this is what that advanced dynamic analysis room that I was talking about. So I already did a couple of videos about the basic static analysis. Hopefully, I'll be able to do this uh, dynamic analysis room as well, and I'll put this as a video. And look at this, the x64 DBG. Uh, this is the interface, and opening the file in the debugger. Then system breakpoint is reached. So that is the first point. Then I should go to break. Okay. The execution of program is past the system breakpoint. We can control whether to execute one instruction at a time or the whole program. But before that, let's take a look at the screenshot above. We can see the disassembly in the middle pane and the instruction pointer pointing to the next of the instruction we executed the starting program. So here is the instruction pointer. Right pane, we can see the registry and their values. We can note the EIP, the pointing to. Bottom pane, okay. Let's look some of the other tabs. The breakpoint tab shows the current status of the breakpoint. So once you update the breakpoint, you'll be able to see the breakpoints from here. And the memory map shows the memory map region. Okay. And you can also see the call stack of the program. I'm not sure what it is, but maybe the stack. Stack is a memory structure in the CPU. Threads running in the program are shown in the threads tab. Okay. Handles, any handles to files, process, and other resources can be found in these handles. Okay. Debugging in practice. So this is what quite important to us. And in the debugger window, it just opened. Among these from this execution, let's see the execution okay. Program is changed and then paused. Now TLS callback. Come on. Now we can see how control execution. Let's execute the program by pressing the arrow key. If we do that, we can see the bottom right corner of the program status changes to running, then paused. Along with the status, we have the reason for pausing the execution: INTL3, breakpoint, TLS callback 1. I think this was the breakpoint it reached at the program's entry point, I guess. We have hit TLS callback, and the the debugger was programmed to break the execution on the TLS callback. Okay. I think I should have done this before I did execute the binary. In the debugger, this is the part I was missing. In the debugger, we can put the automatic breakpoints on the programs by going options and the preferences menu. We can see that the DL connotation are checked. System breakpoint, entry point breakpoint was, I think, default it is checked. The TLS callback, I think we can put the checkpoint here, and the system TLS callback is also, which means the TL execution will be broken at this event. Since TLS callbacks are often used as anti-reverse engineering technique, we should be careful when navigating TLS callback. TLS means thread level storage in binary analysis. So I'm trying to learn that concept from the scratch. So once I learned, I'll try to share it with you. While we are at the callback, clicking discussed about. Oh, come on. here it didn't mention about stopping at main function. So they just mentioned about applying the breakpoint at the TLS callback. I don't know whether it's gonna help us, but let's try that. Preferences, options, preferences. It's already checked. Use TLS callbacks and system callbacks is already checked. I was never sharing the screen, pardon me. So actually what I was doing, I was referring this try hack me dynamic analysis tool. So here they mentioned like how to start doing the debugging with x64dbg. So I was referring that. It's already checked. Engine, exceptions, disassembly, GUI, miscellaneous. Okay. I don't know how to use these plugins, but maybe if I learn how to use these plugins, I think it's gonna help us. Automatic analyzer is checked. I need to learn that. I need to learn how to use these plugins, so it's gonna help us while debugging. But for now, I think we have answered some questions, so I think it's time to start the next recording. Hey there, hello everyone, Perumal Jagan here. We are doing a malware analysis. We are trying to analyze a complex Go malware. I'm not familiar with the advanced malware analysis, especially using a debugger, but we are actually started learning this, and we started with the difficult binaries, Golang binary, and we've answered few questions. We managed to answer few questions by using debugger. Now I guess it is time to switch to the screen and do the rest of the things. Yes, so you are seeing the x64 debugger screen, and I can see in front of my eyes, I can see a couple of curl commands and followed by a PowerShell command, then some host name. You could see here host name, ipconfig stuff. I think, look at this, let me scroll right side. So looks like it could be trying to collect some data, host name, ipconfig, and go string hijack locations and sending them as a data. I don't know, maybe it might be trying to grab or collect some information from the system and try to pass here. Country, city, VPN, private key. Okay, some geolocation probing. So what I can understand is this particular malware is trying to enumerate some system information, then it tries to check the tries to use this particular API used to check the geolocation, right? And then this one actually once it grabbed all the information, it actually downloads the malware from C2. So that's what happens. Then PowerShell execution bypass to execute this GoTeam binary. So that's what happens here. So it actually does the execution as well. So that's the purpose of this MC mod maker version 1.4.exe. So from this, I think we can understand. So this is the screenshot they took and they posted in their write-up. So with the bare eyes, I thought this is actually in the disassembler. Then I kept searching for these strings inside the disassembler Ghidra, but in fact it was x64 dbg. Fine, I go to the challenge page. What's the next question? While analyzing MC ModMaker version 1.4.exe, what format is the data that is returned to the C2 server? and I think I should be referring this right up this time. If I scroll down, let's see what's the value of API key, and we got that already. GoTeam.exe is a domain name, that's fine. And here is the execution. Continuing your analysis, our geolocation check is failed. The malware is using PowerShell again to perform downloads, which no doubt is the encryptor. We can clearly see this is the C2, fine. Okay, continuing the debug in the same binary at offsets. So they also gave some address, D34268, sorry, D34268, D326AA. We observed error related to JSON outcome. So from this, they came to the conclusion that this is actually the application JSON. Where is the document? So in this, if you see the official write-up, I think they uncovered it here. We can further analyze main.send discard, and inside it we can see that the data gets sent to the attacker discard in JSON format. We have Ghidra opened here. Static tools, advanced static tools, Ghidra. Opening it. Modmaker.exe, and now we go to namespace. Main, inside the main.main, send to Discord, right? Send to Discord, yes. Come on. Yes, here it is. In send to Discord, did they mention about the type? Application data. Let's check this out. Posting, content type, here is the URL, the webhook URL, send to Discord. I think I should scroll down further. See how huge it is. Even if you create a hello world binary in Golang, it will be huge with bunch of functions, and that makes this reversing of Golang quite difficult, or a hell, I would say. Okay, let's go to this lab, into this debugger. If I scroll down further, error running the command. and look at this error sending to Discord. So based on this only, they came to the conclusion that this is using a JSON format. Can I just use the same thing, but I'm just trying to see outcome like this. Application JSON. Can I see them at least anywhere? Error sending it to the Discord. I'm getting this error. I keep getting this error. Okay, I go and try to answer this question. Can I go to this particular send data Discord defer wrap one? Can I go there? Gitra. Main Discord defer wrap. Yes, this one. If I scroll down further, can I see application JSON here? I don't see them. Okay, I'll just use that write-up reference and give the answer. So it's JSON format. What format is the data that returned to the C2 server? Yes, that's the thing. And what specific file type is enumerated by goteam.exe for encryption? So I got the answer for this. So let me tell you how it is. I go to this code browser. So I open goteam.exe as well. And now if I go to namespaces, now we are in the goteam.exe binary, exe binary. I'm going to main function, inside the main function, and look at this one. This particular part, this is what I wanted. I just go to main function now. Let's go here. So inside the main function, if I scroll down further, I could see trying to read the directories. So it is trying to read the directories, trying to do some path join operation. If I scroll down further, find text files. So what it does, it actually tries to find the text file, then doing some encryption. That's what I believe. That's what it does. Let's see. It's quite it's little better to see this decompiled view. Text decode string, finding the text files. So if I go to find text files, what happens? So for walk directory, so this particular stuff is actually trying to find the text files in the directory. Yeah, so I believe it's gonna be a text file. The text file is only get encrypted by this ransomware. What is the full string that is displayed when goteam.exe enumerates in restricted Windows folder? So what it does, looks like this goteam, the ransomware encryptor, try to enumerate a restricted Windows folder which that ransomware doesn't have access to. Then what sort of error, what is the full string that is displayed when the error is triggered? So how we can find that? I think it should be found from the debugger. Let's see. Just scrolling down. Yes, this is the answer, but how to find them? This behavior suggests the encryptor may not have access to certain directories. By searching the error handling related strings, I found references indicating some directories explicitly skipped. Sort of higher level explanation in this write-up. I scroll down further. Do I see any detailed explanation here? What is the full string displayed when GoTeam and is enumerated restricted Windows folder? Skipping directory. Can I see them inside inside a Hydra? Let's see. Code browser, not this one. This one. Oh. GoTeam.exe. Search for strings. Search. Yes, here if I go and check for skipping, when I go here, can I see anything? Oh gosh, here it is. But how to find them? Because I referred the write-up, but without referring the write-up, how I could have find this? Shared library. So here are some messages. Then here is the directory. .4e620a. That was the address. Similarly, can I see application JSON? No, that one not found. But the error message, it is obvious. So this was the error message. I think they have defined this message in the printf statement of Go source code. So that is how it spotted. Fine. I think this is the answer. I go to this Linux machine. I think /n is not required. Okay, so this is the answer. Fine. Within the encrypt file function, in case the file was read successfully, what is the function name found in the call instruction? So within the encrypt file function, so let's go there. I go to Ghidra. Come on. Encrypt file function, and I see them. Encrypt file function. Okay. I think this one. Yes, let's see. I think inside the encrypt file function, I'll be able to see all those strings when it is trying to read a file don't have access to. I think, yeah, error reading the file. What was the answer to our previous question? Keeping the directory. I think I will be able to get that here as well. For now, I think we need to answer to the question. In the inside encrypt file function, in case the file was read successfully, what is the function name found at the call instruction? So we are inside this one. I should be checking for the call instruction, right? So let's go there. The file is found. What is the call instruction? Error reading the file. So this is not a call. This one, maybe. Yes, I guess that one. Crypto AES new cipher. So here it is. Before there was an error reading file, but if the file found successfully, I guess it actually looks for crypto AES new cipher function call. Let's verify this with the write-up and look at this. Reading the file followed by this function call inside the encrypt file. So that's the answer. Crypto AES new cipher. Copy. Go to this one. These strings separated by underscore. And that's right. That's the correct answer. All right. Now, what's the decryption key? So there are only 2 questions to answer. I think I can try to finish it soon. So I already reached 20-minute mark. Doesn't matter. So I'm just going to finish it here. What's the decryption key? What is the name of the project in the encrypted.txt file? So I need to find the decryption key now. How to find out? Let's go and check this write-up, the same write-up. Since the encryption logic relies on AES, okay, the same key is used for both encryption and decryption. So that is how the encryption in AES works. Crypto AES new cipher. Let's go and Google it. I go here. Crypto AES Golang. New cipher, that's the function. So this is what we just witnessed. Function new cipher, source file aes.go. Here is an example code block. Function new cipher, key cipher block. I think so the same key is used for the decryption as well. So that's what they try to say here. So here, if I get into this AES, this cipher routine, the AES cipher routine, I think I'll be able to uncover the decryption key. Let's see. Maybe how I can do this. Let's see. AES new cipher, key size error, more stack. Okay. Do I see any hard-coded key here? I'm just trying to find them if it is. You can see this function is actually getting the key as an argument. inside the encrypt file. Here is the function call. The variable 9 is actually storing um, the key, I guess, in this crypto AES new cipher var 9. So this is the function call. So in the function call, I can see the argument var 9. So which is the key? Because if I get into this new cipher, I could clearly see when it is calling this new cipher block, the key is actually passed inside this as an argument. So it's pretty clear that I need to find that variable 9. How I could find them? Maybe what I can do, I need to stop at some point. Let's see. Error reading file. After error reading file, how long does it take to come to this part? Error reading file is in the 4B7272. That's the address. 4B72C0. So I think if I get to this, or maybe if I try to stop somewhere here, I'll be able to uncover the variable 9, which is the key. Right? Let's see the write-up. That's what I assume. I just need to confirm it with which is quite correct. It was correct, yes. And look at this. This is the block. Crypto AES new cipher var 9 and followed by some variable setting, and I could see the call here. So looks like in this area only I should stop while debugging in order to find the key. Okay, now let's see. Since the offsets differ, the easiest approach is to search for the nearby strings for error reading file. I began analyzing the surrounding assembly strings instructions that decompiled in Vidra. Search, set the breakpoint at 3C72C0. How did I set the breakpoint there? I think 3C72C0. They set a breakpoint somewhere here. Error creating cipher, right? I think they set here. PC72A8. Okay, now I go to debugger. So inside this debugger, I should go to this place. I think now I loaded the modmaker.exe, right? I should be loading a different file now, goteam.ext. Okay, I have loaded it, and let me enlarge this. It is done. I search for the string. If I scroll down, can I see them? Now it is in the system breakpoint. Now let me go and run this. So X analysis is doing extended analysis. Now I think I'm stopped in the entry point of the GoTeam binary. Now this is fine. When I scroll down, or I need to do the string search, right? How to do that? I was just doing this. View, not view. Debug or tracing, or plugins, favorites, options. Come on. How was I doing this? Not a memory map. Let's see if it's script symbols, no, source, references. Okay, I think inside the references, all module strings. Okay, I got it. We need to go to CPU, search for all module string references. So here it is, and inside this, if I scroll down, do I see the string where it was like okay, go to Ghidra. I already know the string that I need to look. The string is error reading file, right? That's the string. So I copy this, I come to debugger and I search for this string, and look at this. This is here. But there are 4 occurrences. So let me apply breakpoint at each place. Toggle breakpoint, sorry, not toggle bookmark, toggle breakpoint. I'm pressing F2 simply to apply the breakpoint. Okay, now I apply the breakpoint. What I'm planning to do, I'm running it. I go to CPU again. Come on. Debugging stopped. Okay. When I run this again, I'm hitting a point. It says system breakpoint reached. So let's see a breakpoint now. I actually have breakpoint in various places. 10337B2. Come on. E5E. I don't know where I stopped right now. I'm running this. This is the entry point, address of the entry point. Debugging stop. Come on. I go to this one. I'm restarting this binary. System breakpoint reached. Now I'm in which breakpoint? I think E5E. Maybe this one. Oh gosh. I need to run this. Now I am in the binary entry point, which is DC80. No. Yeah, I think that breakpoint is hit now. That is why it disappeared. Now I go and run again. Debugging stopped. Looks like it is wrong. So I restart this. I run. I hit the binary breakpoint. Now at this point, if I right click and search for current module string references, can I see error handling file? Yes, here it is. So I remove this, remove breakpoint, and now I'm just applying breakpoint here. 1047255. 1047255. Now if I simply run, what happens? It again says debugging stop. What is the mistake I did? 3C72C0. Since the offset differs, the easiest approach to search the nearby string error reading the file. From there, I began analyzing the surrounding assembly instructions. correlating them with the decompiled data in Gitra. 3C72C0, highlighted one. Go to search for string references. How about skipping directory? Yeah, no, wait. Error reading file. So because that was the previous string to this function, I'm just copying this. Or if I go to this one, do I see any string within this? No. Oh. Error reading file. One 1047255. If I can go here, follow in disassembler. Yes. Okay. But I guess this one is not at all reaching. Then in the write-up, what was that? Come on. 3C72C0. So before error creating cipher error, create DBA0 routing. Scrolling down. So before that, at this point only they applied. You see, error creating cipher. So before this, they have applied breakpoint somewhere here. Which one it is? So here is subroutine, goteam.sub, another function call. So let's see what it is. So here is the error. Before that, there is one jump equal, and there is one call and another call. Okay. Jump instruction, call, another call. I guess this one. I guess this is the subroutine that I want. Can I apply breakpoint here? Yeah. Then what should I do? Then follow the dump value at offset A8. So once it hits this breakpoint, 3C72C0. So whatever the breakpoint we set, once it hit, I guess, yeah, I guess it should be checking for the dump in this particular 3C72A8 address. because this is the function call. So before the function call, it is trying to form, or it is trying to craft the key. So that's what it is. So let's go and see this error reading file. I think this is fine now. 4747 to 104728. I think this is where I should follow the data. Okay, now it's pretty clear. I'm just removing this breakpoint. Edit. Come on, I should remove this breakpoint now. If I press F2, it removed. Okay, now I have only one breakpoint. I run this. I don't know whether it's gonna hit. It says it's terminated. I don't know why. Search for all modules, string references, and go to disassembler and bring the I go to search for all modules, string references. Inside this, I'm pressing this and just going here, follow in disassembler, and when I execute, why it's not hitting this breakpoint? I really wonder why it isn't hitting the breakpoint. So this is the call. Let me do one more ChatGPT search. This could be the final search. I think this video is already reached a 40-minute mark. So it's going to be 2 huge videos that I'm going to upload. But okay, I go here. Come on. 0 uploads at a time. Okay, I do one thing. I bring my base machine's ChatGPT. I have uploaded this. Why this breakpoint is not hitting? Maybe it's not even trying to encrypt the file when I'm executing this with debugger. Maybe how I can just make it to encrypt some text file. How I can do that? I think I should refer this right up. So here he was doing some things. Let's see. Skipping the directory access denied. Okay. Yeah. They actually created a folder and they put bunch of files within that. While debugging activity, I observed that output indicating that the malware has detected the .txt file, successfully encrypted it. An interesting finding. Okay, now what I can do, maybe I can create a directory and put a file. To test it, I place the ransomware in custom directory, add several files with common target extensions. So they are actually placing this ransomware in the same directory. I executed the sample but observed no activity, but when they did from C uses public, still saw no activity. Okay, I think they need to put some txt file within that directory to trigger this encryption. So now it is not even hitting the encryption routine. That's why we are not seeing any error. We are not seeing any hit to our breakpoint. uh, I go to this lab, then this path, uh, PC, desktop. Okay, I go to desktop here, sample, mod maker, danger, and this one. Okay. Okay, let me copy this. I go to not desktop, maybe some other directory, or I create a directory here. Okay, on this C drive, new folder, test. So within this, I copied this binary, and also I'm going to create a text document, test.txt. This is test data. I'm storing this. Now I'm planning to execute this, maybe without debugger. Let's see what happens. It executed, but I don't see any activity. Come on. Maybe can I do it with debugger? Exit, closing debugger. I'm going to desktop, opening the debugger again, open a file, maybe not from here, from C drive, test, go to, and now hitting run, it reached the entry point, and let's say is there any access restriction to this file? I should find that. Maybe what I can do, I go to not breakpoint, search for all modules, string references, and I need to get one answer that we already made. Skipping directory, access denied. So this was the error message, skipping directory. So let's go here. I'm just trying to confirm whether it's skipping the directory. Skipping directory. So this part. So I follow in disassembler and apply a breakpoint here. Now if I run, I think the breakpoint is hit. Look at this. Now the breakpoint is hit. To get your files back, gotta pay this. TXT documents. Did I hit the breakpoint now? I go here, search for all modules, string references, skipping directory 776F6A. Follow in disassembler. The breakpoint is not hit. So I hit only this one. I go to follow breakpoint. Yes. And it hit this one. Come on, go to breakpoint, follow breakpoint, then I hit once again. Maybe I'll hit one more breakpoint here. Error creating cipher file. I go and run this. Now I could see there is an internal breakpoint. So it is currently here. I hit once again, run, it stopped. So looks like I guess this one is not even encrypting. But how I can make this file to encrypt? I mean, I need to make this binary to encrypt the data for me. How I can do that? It's pretty lengthy now, so I'm stopping this recording here. So I'll continue this part in the next recording, the next part. In the next part, we're going to see how to uncover the decryption key in detail. Okay, so let me stop this here. I'll catch you next time with another exciting one. Okay, I think it is done. So I made 45 minutes video, couple of 45 minutes video, which is pretty huge, I can understand, but still I need to uncover answers to a couple of questions, right? Actually, I learned a lot with respect to disassembling, debugging a malware. So earlier, when I used to see any executable file, it felt like pretty intimidating. But now, I guess I got some confidence that I'll be able to solve reverse any binary, because we are doing Golang binary, which is quite difficult. It's not like reversing C or C++ binary. Okay, I think it is time to start this again. I don't know how it's going to end. Let's see. Hey everyone, my name is Perumal Jagan and we are doing malware analysis. We are trying to reverse a Golang binary, difficult one for me at least. Haven't done this before, so I started doing this with this challenge Malware mod maker. So let me share my screen. We are going to do the last part of it. I guess this is going to be the last part if everything goes correct. Okay, now this is the Malware mod maker. We need to find the decryption key and the name of the project in the encrypted.txt file. So our first thing is, the first part I need to do is to find the key that used to encrypt it, because this is using AES encryption. So the encryption and decryption is obviously going to use the same key. So it's not going to be difficult if I find the encryption key to uncover the file. Now I got the folder test. Within the test, I am having the goteam.exe binary, and I'm trying to run this binary, and I'm just trying to just encrypt this one, but unfortunately it is not encrypting. I'm just trying to find a perfect case to bring this directory and run this again. So let's see in this write-up how they did. I then tested it on another directory with unrestricted read-write access, but it still saw no activity. Okay. While debugging in XTV offset, error creating .txt. I also the output indicating the malware has detected .txt file in the document folder, successfully encrypted it. Interesting find. To verify this behavior, I copied all the previous tester files and documents. So looks like this malware is actually encrypting only the file that present in the documents directory. I guess I also came across this part. If I rerun, come on. I'm just minimizing this. I run this. Error creating hyperfile, and look at this. So here is the message. See analyst document. So I guess error reading the file, but I think I should put the documents in this directory, documents directory, to encrypt them. So that's what I'm planning to do right now. Yeah. error writing encrypted file. Yes. Error creating d.txt because the file was not in the designated documents directory. Now I guess this is time to put it in the documents directory. So I go and copy these two, go to local documents, and I see this one is already created the d.txt file when I ran the malware. I'm just removing this. So there are a bunch of things in the download, but within the document, look at this. Yes, here's the d.txt file and its encrypted version. It actually encrypted this d.txt file itself. So I'm just going to delete them, then put it here. If I run this binary, maybe I should be able to see this. Yes, you can see this. The test.txt file got encrypted. So now I'm going to remove this one, and let me start this debugger. I go to open. Okay, I think I should be going to debugger, desktop. Yes, here it is. Now I'm just opening the file from documents directory. So here is the documents directory. So I'm clicking and opening this file, and what I need to do, I go to this one, error reading file. So I need to go here, copy this particular string, right click in this, search for all modules, string references, and it loaded. And copying this, searching for the string error reading file, then going to this path. Where is that error reading file? Yes, here is that error reading file. And now if I go and check this out, error creating a cipher file. So before this, I think I should actually stop here. So this should be the breakpoint, not this one here. So I press F2 to remove this. So this should be the breakpoint, 772C0. 772C0. So I'm removing this one as well. This is actually the entry point. So this is the only address that I need to stop. I go to CPU view, and I'm just verifying this before I run all these things. So once I hit this breakpoint, 772C0, I need to click this one, and I should go follow in dump, memory map, follow in dump, I guess, to extract the key. Now it is time to execute this. So let's go and do this. I think it should hit this breakpoint this time, 772C0. Let's see. Can I run this? Okay, now it is in entry point. If I hit one more time, it's going to hit 772C0. Yes, look at this. It hits the breakpoint 772C0. Now I hit the breakpoint. Now all I need to do is to go here to this particular point and follow in dump. I guess follow in dump the selected address. I guess this one is going to give us a key. Let's see. So it hits that, then when it hits this, follow the dump value at offset A8. Okay, at the dump table below, not the selected address, I think the value to be dumped. Yeah, I go here, click this part, follow in dump value. So I'm dumping the value present in this particular spot. I could see the value here. Change this pass, user data. So this should be the key. Change this pass. Yes, so this is what the key, I guess. So let's see how we can just grab this. Can I grab this by clicking this? Copy. What if I click address? I think it's gonna copy this address only. Let's verify this. Come on. Yes, it copied the address only. But what if I need to copy this particular address? Copy selected lines. Now I can see this. So this is gonna be the value of the key. So I'm just removing these spaces. So this will eventually be the key. Now if I see this here,
The seasons come and go like thoughts of you.
yeah, I think this is what the key. Let's try this. Sherlock, add the box. Is the key correct? Come on. Am I copying this properly? Copy. Paste. No, I'm not able to paste this. Copy selected lines, go to this place and paste this. No, I can't paste this. Weird. Then how I can bring this? It was working. Come on. 63686166765207 I think I should be typing this and printing this. 63. Can I just paste this? No. 6368 61 6E 67 65 20 74 68 69 73 20 7061 7373. Let's copy this. Go to this box. Is this correct? Yes, that's the key. Now it's quite simple to execute this binary and execute the decryptor binary and uncover the encrypted string text. Okay, now I can see this pruh.exe. If I execute, it is actually asking me to enter the key flag. The key flag, okay, let me go and check this. Decryption key. So it's gonna decrypt all the files present in the current directory, including this one. Let's see the key. Come on, I think I lost it. Here's the key, and when I give the key and enter, and look at this. It found one file, and there were multiple zipping directory message. So it tried to access all this directory, but the permission denied. Eventually, it decrypted and restored the file here, probably important.txt. Now if I go here, I could see this probably important.txt file. I click this and look at this. This is the message that was encrypted. Internal software requirement specification, AI coding chatbot. Okay, so this is the message that this is the file that got encrypted, and the project is this one. I go and add, so come on, it's not working. AI coding chatbot, that's the answer. AI coding chatbot. And with this challenge, Malware mod maker is done. Oh, hopefully, I think during this whole assessment, I did not touch the dynamic analysis part. I mean, I did it with debugger, but I did not do it by simply executing this and throwing the files like procmont, regshark, capturing the traffic with the Wireshark by enabling inet sim or fake net tool. So I did not try all those things. Maybe I will be trying them in another malware analysis video, but I think we have done a commanding job. I think I can proudly say that. I was not sure like how I'm going to do that, but hopefully I did refer the write-up, but I learned a lot. So there is nothing wrong in referring a write-up if you instead banging your walls against banging your head against the wall. Okay, so that's my advice here. This is time for me to sign off. I'm gonna catch you next time with another exciting challenge. It could be a malware analysis, forensics, or it could be a penetration testing or anything else. Something else. So let's see. I'll catch you next time with another exciting one. Signing off. Cheers, and I love you all. Don't forget to do the YouTube algorithms, like, comment, subscribe. Thank you so much. And yes, the recording part's done. And also, I've been streaming more than 2 hours now. It's time for me to sign off. Hopefully, I guess we have learned something from the stream. In fact, at least I learned something. So it would be a little boring because I didn't expect it to it would be dragged this much, but I didn't expect to see a Golang binary first of all. When I see this Malware mod maker, I was literally thinking of examining a .NET binary or a C++ binary, but not the Golang binary, to be honest. But anyway, we did that. We did finish it. That's it. I don't have anything else to mention. Yeah, we'll catch you next time with another exciting one.